Hi all, welcome to the Way Forward Talks. The Way Forward is a company where we are into working with students and professionals, helping them and equipping them for the way forward in the career development. We are into career development and hobby development. We start with resume building and we also prepare them for the interview and post interview at their first job or their job as a whole. So we are commemorating Engineers Day, and we have a great, talented, and amazing engineer with us who graduated from BITS Pilani, and then he went on to do his master's and his PhD in Boston University, United States. So he is a great leader. He has been leading many teams since the time of his college and earlier. So we would like to learn more about it and how to help and grow many people along with himself. He has been growing many people and he has grown to a great level. So we would like to hear more about it from him in his own words. So welcome, Mr. Radhakrishna Sanka. So happy to have you here. Or Dr. Radhakrishna Sanka, rather.
Not yet. Not a doctor yet. A few more months. Gonna defend soon.
No, that's great. So all the best for that. And welcome.
Yeah, thanks, Amrita. So I think you gave a really flattering introduction, and I can't stop blushing at this point. But yeah, so so I usually go by Krishna. Most friends call me Krishna. I think in undergrad people used to call me by my last name, Sanka. So a lot of people know me by that name back then. Yeah, so I'm a computer engineering graduate student at Boston University. I'm towards the tail end of my PhD. Like, I need to actually finish writing my thesis now so I can actually defend and, in the next 2 months. So I'm basically like, oh, so many things I need to do before I graduate. What I basically do for my PhD is I look at how engineers engineer life sciences, both in terms of like engineering genetics, genetic constructs, and also folks who are engineering devices for doing all the life science experiments on them, automating those life science experiments. So I look at how they make these devices, I look at how they think about engineering, and I basically create design tools to capture all the engineering process and automate a lot of those things. That way, like if 2-3 different people are trying to do the same thing, you don't necessarily need to teach them how to do everything, but rather you give them a tool and a workflow they can follow easily, and it captures a lot of the complexity. If we think about how we design electronics, right? Like nobody knows, like your average electrical engineer in your undergrad doesn't know how the quantum mechanics or how to engineer the semiconductor states work. But at the end of the day, all that stuff is happening, and you have something as complex as an Intel processor with like 1 billion transistors. You can't do that without the software and the automation, design automation. And that's essentially what we try to replicate in life sciences and engineering these biomedical devices.
Amazing. That sounds really great. And it's really nice that you're in that line. So very happy and good to be connected with you. So we just start off with some questions and we go deep into it. So as an engineer, you have been aspiring to be an engineer since life, or how did you take the decision of becoming an engineer?
Science was always cool growing up, but I don't think, in all honesty, like looking at my grades or my attitude at like 10th grade, I didn't think I would be an engineer. But, I came across a couple of open courseware lectures from MIT in my 11th grade, and that completely shifted the trajectory for me. I could suddenly keep up with my courses in high school. And then, once you start doing stuff, you listen to cool people talk about science, you get more and more involved in it. And by the time I came to BITS for my undergrad, I was like, yeah, no, I want to learn how to engineer electronics. And so I came in for my electronics and communications engineering undergrad.
Amazing. Great, that's nice. Awesome. So as a student of a prestigious institution like BITS Pilani or Boston University, you happen to have many venues to participate and lead teams or be a part and make a good impression on everyone. So how was that experience and how do you feel to be participating in such activities? Is it important, and if so, why?
Actually, yeah, no, it's funny because I literally had a Twitter rant the other day where I was talking about how having access to communities is super important. I think bits was very important, and like it was a new campus when we started our undergrad, and so there were a lot of things which weren't yet formed. But the people you're around, surrounded by, and everybody's ambition is what drives you to move forward. And I would definitely attribute, if you can attribute any success in my life, a lot of it only started because of the people I was surrounded by, my friends and the people who were pushing forward, and like out of like sheer competitiveness, or like friendly competitiveness, you also try to push yourself forward. So that was important. But again, coming to Boston University was also super. I have like two experiences in Boston University. One is during my master's, where where I was a master student who was new to the place, didn't know anyone, anything, and just trying to survive the system. Right. I was doing my courses, I was doing them well, and it was fine. But at the end of the day, it wasn't too much. But when I started my PhD program with my current advisor, that was when I really got a chance to spread my wings, start talking to people. It's about what environment my advisor also created for me to do things the way I want. Like my first year in PhD, I was assigned 5 undergrads to work for me. Partly because their existing mentor needed to do a different fellowship, so he had to move to a different research area, different research lab to work over there remotely. So they got assigned to me. But the point is that that ended up allowing me to go to this competition called iGEM, which is like an international genetic engineering competition, but it has like 400 teams from around the world and stuff. So our team did very well in that, and that kind of pushed me even further into like the whole community of synthetic biology and folks who are engineering licenses. I think it's been a very important part of how I've become and where my career trajectory is, what I'm shaping it to be right now. Similarly, right, like conferences and stuff, when you go there, you talk to people, and being in Boston, being around universities like MIT and Harvard really gives you an advantage because there's so many smart people in the area that the osmosis and being able to just walk around, talk to different people, you meet in like random science socials and stuff. And so all of that is what really makes you think beyond whatever you're thinking of right now. And yeah, the community is important. Like without community, you can't have innovation.
So true. It's like you grasp information from any direction possible, and the community actually paves the way for that. So it's amazing.
Exactly. Like there is like it's all a creative effort, right? Like when you want to innovate, it's the creative effort. Most people think of engineering as to be kind of like, oh, it's not creative, it's a science, it's not an art. But you're applying it, the way you apply it itself is an art. So in those kind of creative endeavors, you need to be like, no artist survives without being surrounded by other artists. And similarly, no scientist or engineer survives without being surrounded by other people who are trying to push the boundaries of what's there.
Very true. Perfect. That's awesome. So as an electronics engineer, there would have been many challenges you would have come across, maybe in your undergrad or in your post. How do you come across those? How did you come across those such situations?
I think that might be very open-ended. I could probably try picking 1 or 2 challenges, and maybe that would help. I think one of the earlier challenges is, if you're an electronics engineer, at least in like the BIT system or any Indian university system, you're actually thrown a whole bunch of different fields at you, right? Like you learn everything from control and optimization to doing like digital design and whatnot, right? And as I've seen like how undergrads are trained in the US, and while I envy the fact that they get to spend more time in each of these courses, have a chance to grow more, the fact that this whole, throw everything at you and not really be a master of everything kind of did help me, because it lets me navigate these intersections of fields, which is what I do right now. Like I am not like an expert in any one particular area. Like I know like 10 people who build better analog designs than me. I know another 10 people who write better algorithms than me. So, but like I try to tie together all these different things, and that's where I kind of made it my niche at the very least. So I think that was one of the things, like being able to just capture like different types of information and keeping your mind flexible to move in that. I think that is one aspect. So the big challenge in that is you need good instruction over there. And, like most students who will be watching this probably know that, like instruction is so-so in any university. No matter how big or small, you'll have bad instructors. BU has instructors who are not great. BITS has instructors who are not great. You can go to the best universities in the world and you'll have some courses which will have like very, very bad instructing. The most important thing is know that, you're doing these courses for yourself. If you're an engineer going down the engineering path, all these courses are not something that, will get you a job or that you'll use. It's something so that you can change what your creative outcomes are, right? Like, it's like learning how to paint with like a brush or like a knife or whatever it is. If you know how to do it, you can actually talk about it or think about using that later on. But if you ignore it and you keep rejecting everything that's coming, saying, oh, where will I use this? It doesn't matter. I was just fascinated by, how crazily you could use the math everywhere. And that's what just strung me through, right? But later on, when you start thinking about, and that's why, like in engineering biology, most of the ideas people use to engineer biology, the abstractions they use are basically what people use in digital electronics and analog electronics, and sometimes control systems. So when I look at these things, I don't need to know any of the biology because I didn't do anything beyond my first year of undergrad, right? I didn't do any more biotech after that. But because I understand how digital logic works, I understand how control systems work, I can have conversations with the life scientists about what they're doing, and then have rational conversations about, okay, maybe that's not the way we need to design it, or are we doing this the wrong approach? Again, I can't probably tell them how to do it better, but I can probably say, you're trying to solve it this way. Maybe that's not the right way to go, because look at the graph you're looking over there. That's the kind of control loop you want to design, and what you're doing is not going to work. So I don't know if that was abstract enough or if I dug into it too much.
Yeah, perfect. I mean, it gives a lot of picture about how to keep oneself open and try to, as much as possible, fit into the situation. So
yeah,
I also
definitely
attribute everything I did because of BITS, because BITS has given us the openness I felt. So that's a nice thing. Great.
Yeah.
Nice, great. So now we have spoken about what we have done like in your journey. So as you have grown, you went into doing masters and now you're doing a PhD. So how should a student, once he's done with his graduation, maybe in his BS, how should he think whether he should go for an MS or go for a job? What do you think is the right indication for him to take up a master's or a job?
So in my case, I did end up working for some time. And then I decided to do a master's because, I realized there was a glass ceiling in the startup I worked at. As like my project manager, was not a great project manager, but I was like, I know more than him, but the only reason, nobody's listening to me is because I only have like, bachelor's. So which is why that was like a very petty motivation to go into master's. But more than that, I was like, what, I've done this whole thing of integrating existing engineering designs and systems, because that's what I was trying to do during that particular job. And I was like, what, I want to be closer to the physics of engineering. I want to be a person who can engineer the actual physics of the device to make it do the thing, right? Whatever that thing was. So that's how I ended up going for my master's. And when I did my master's, I thought about like, what are the fields I want to go in, and what are the centers, like geographically, what are the centers where a lot of work is going on? So Boston, and so because I had this whole wide array of, I always have like a million interests, right? So I was like, okay, if I go to the Boston area, it'll be somewhere close to like nanosciences and whatnot. If I go into like Georgia, Atlanta, it'll be like a different robotics kind of a thing, or CMU was robotics. So basically I had like different things for like different areas I'd go. Because I came into Boston, I went more into like the photonics engineering and more of that. So for me, it was a lot of personal motivations. I understand that most people who are doing a master's and coming to the US or going anywhere abroad, again, going to Europe is also a great idea. What you want to keep in mind is think about what are the fields you want to go in, what is the recruiting like in the area where you're going into. So that's where it was a mismatch for me, because I was in photonics and I didn't really have like industry backups, because most of the photonics jobs were gone to like especially the kind of photonics I wanted to do were gone to like folks with like US citizenship, because most of them were defense labs around here, or you needed like US citizenship and security clearances for doing those roles. So but I was anyways planning to do a master's, so it didn't really matter. But those are kind of the things you need to keep in mind when you're thinking about doing a master's and stuff. And more importantly, do something that you really want to do. Think about like what your career growth requirements are, right? Because when I did do a master's, while it was a petty motivation, career growth was an important aspect. I wanted to be able to lead teams to engineer and stuff. And so I figured having a master's or being able to lead teams, being able to do more specialized engineering work, deep engineering work was something I wanted to do. So which is why I went ahead and did a master's. If you are in the right kind of company, you will get to do a lot of deep engineering. You don't need to do a master's per se. So that's the difference, right? Like, because there are companies where you create IP, there are companies which integrate IP. If you're in a company that creates IP, you'll get to do a lot of deep engineering work. If you're in a company that only integrates stuff, yeah, you learn a lot of things. Integration is not an easy job. But at some point, you might want to do a master's because you want to get deeper into like design and engineering. For a PhD, a couple of years back, somebody asked me this, should I do a PhD? I was like, do you want to do a PhD? And that's the real answer, right? There is no reason one should do a PhD unless it is something that you want to do for your own unique reasons. I had my own unique reasons. There were things I wanted to do. I was thinking in terms of like impact, what I can do, what I can contribute to science and humanity and whatnot. Very lofty goals, but that's how I was approaching it. So for me, doing a PhD made sense because I wanted to do more research. I wanted to tackle harder problems and see if I could solve them. So it was my own personal motivation. I know folks who do PhDs because they really love the science and they want to explore and answer questions and everything. I had this one mentor during my master's. He was engineering lasers. One of the top people in my university when it came to photonics and lasers. For him, it was like, for him doing a PhD meant like, here's the knowledge arrow. If this was a knowledge arrow, what I'm doing will make sure this arrow is slightly longer at the end. I wasn't interested in doing that for a PhD. I was interested in making new things. So I was more interested in the application, putting together different ideas and coming up with new stuff. But he was interested in discovering the theory, formulating, understanding the physics and nature of things. So you should have your own reasons. That's the most important thing because PhDs are hard. Between the environment set up by different universities, which can range from good to bad, environment set up by PhD advisors, which also range very much from super horrible to like super good, like in my case, you will have a range of possibilities of what you might experience. So you need to be ready for what you want to do and why you want to do it. Because when you need to make a decision of whether or not you want to continue doing a PhD or drop out of the program, there's nothing wrong in it. About 30% of the people drop out of the PhD programs. And there are good reasons for why they do it. But you should be able to do that quickly because you don't want to waste your life doing something you're not happy about in an environment where you're not happy. So.
Amazing. That was a very complete answer and really nice. I'm happy for your journey as a PhD student and aspirant and doing great. So now we have spoken about when to think about PhD or master's, how to decide that. If not, if even after a master's or after bachelor's, how should the student prepare themselves for the job market?
So I think the best way to actually prepare for the job market is to actually work on projects. This is throughout your undergrad. Unfortunately, this is not a thing where you can say, "Oh, I'm going to spend my 4th year sitting down and working on a project." It has to be something you do from day one. And part of it is, like try applying all the things you're learning. If it's like a simple electronics course, try putting together like a simple timer circuit. There are like so many DIY resources out there. And I believe a lot of people are doing these things, right? Like going and like building small robots that follow lines and whatnot. I don't know what people do these days anymore, but people do all kinds of crazy things. And that is what you should be doing. You should be applying your engineering all the time. When I'm looking for undergrads to work on projects for me or to mentor, I always, when I look at the resumes, I look at what projects they are doing. I also look at their GPA because, funnily enough, in the West, the GPAs are more attributive to like what the students do, because it's not heavy. Like in the Indian education system, the weightage on memorization is a lot higher. BITS is also kind of falls in that place where they give a lot of priorities to things you don't need to give priorities to. So I look at the GPAs just to know whether they're like dedicated at doing work or not. Because if I assign them work, I'm giving them pieces of my own research assignment, right? So I need to make sure that they'll come out at the end of the day and do the work. So I look at the GPA, but I don't care if it's like a decent enough GPA. I don't care. Like the red flag would be like a 1.0 GPA or something, right? If it's not that. But I also look at what projects they work on, because the projects tell me a lot about what their skills are, like what tangible skills are there. Because if I give them a project, I need them to write code, or I need them to make a circuit or like a device or anything. So if they don't have any project experience like fabrication, coding, or whatever it is, they're not going to be of help to me, and I might have to spend a lot more time than I have to mentor them and train them in those aspects. So work on some projects. It's fine if you're not an expert, right? You tried working on a project, it didn't work out well, but hammering away at it and building up those skills is how you learn. Like my first internship when I was in BITS, like my manager was like, "Okay, so what do you want to do?" I was like, "You know what? I've been looking at microcontrollers and stuff, so I want to learn more." And he's like, "Okay, fine. You have like the next 30 days to figure out how you want to build this particular system that they wanted." And I literally dove in. I was like on like microcontroller forums, reading how things work, and I pieced together all my knowledge from there. So it takes a lot of effort. Don't get me wrong. It means that, you're spending weekends and nights. It becomes your hobby. And that's the best way to do it because, treat it like a fun hobby. And I think building stuff is a great hobby. Like, I don't know about other people, but if you can do something like that, I think it'll be really good.
So true. I mean, there are so many options out there. So picking up one or two will really benefit them and they'll stand out among the crowd.
Yeah, exactly. That and good internships where you actually do something, right? Like, for example, don't go for internships to not do anything. Go to internships and ask people to give you work and do the work. And if it's not a great internship, quit. Like, why do you want to spend a whole summer in a place when they're not asking you to do anything?
So coming into your present day activities, like as you're into life sciences and you're using designing and computing into it, so how should someone entering that domain prepare themselves, and what is the future of life sciences according to you?
So I'm around I talk to the crowd who basically lives, breathes, and thinks life sciences. So for us, biology is the future. That's how, like the people around me think. And, I kind of also think that way because it might be the only way to like actually solve some of the world's biggest problems, everything ranging from like climate change to like how we do resources, extracting minerals from the earth. The only real way to do it in a sustainable manner is to have like some biomechanism, like biomanufacturing or, like therapy. Like if COVID has taught us anything, that is that biology is super important. We need to know how to do stuff. So thinking about what our new sustainable future would look like, we are basically, the world is having to deal with like cataclysmic events like climate change and stuff. So what is the future past those events, like, or towards those events? How can we make ourselves more resilient? Is understanding how to engineer life around us to make it work for us, It can't be this whole extractive, polluting kind of a way to go. So that aside, so that's what I think is like the future of biotechnology. I mean, like the market estimates are also like, like 30-40 billion dollar industry in the coming 4 or 5 years. So there's a lot of space to grow in that area. If nothing else, COVID might have increased the biotech space a lot more. In terms of how do you prepare? So ironically, like the way you need to prepare for biology is kind of like two distinct tracks. One is you're an actual life scientist. The other way is that you're actually coming into like helping life scientists do their work better. So if you're a life scientist, like based on what your expertise is, I'm more in the area of like molecular biology and everything. These are the kind of people I talk to. So you need to be good at doing like wet lab work, like if you need to run a PCR, a mini prep, or using all the equipment and being able to pipette like a mad person. So all those things are things you need to be able to do. I cannot pipette if my life depended on me. And I think my brain does not want to do pipetting. So I will never be that person. But those are the kind of things, people look for. The agility in the wet lab and having some experience is one way to go. The second, if you're a non-life scientist trying to go into life sciences, you need to be good at what you're doing. Whether it's like building hardware or writing software, you need to be able to produce tangible outputs and build things that can go into production, which means that you spent a lot of time working on small projects or big projects, and then essentially, you're able to actually apply all those skills to do something. So it means that, you just didn't take like a programming course and never did anything beyond an assignment. You actually worked on some projects. You tried building some softwares, because that's what, if life scientists need to use your software tool, it needs to be something, like a non-programmer would want to use, right? Like, and that is not an easy thing. That is like, you need to be an industry ready engineer for that. And that's the trade-off. In terms of actual resources, if you're a wet lab person who does like pipetting, molecular biology and molecular and cell biology, you can approach it from, there's an international competition called iGEM. That's one way for you to do. A lot of schools have iGEM teams, field iGEM teams. It is pretty pricey, but, like if there are enough teams talking about like, how expensive it is, I'm sure, like something can be figured out. But that is one way to go. It's a great way to have like a 3-month project experience, engineering an organism and everything. And that's something you can do, even like outside the iGEM framework, right? Outside the competition framework. If you are trying to become a more computational person, in fact, I'll probably share, Amrita, some of these links. There are some websites we put together in our lab for like computational synthetic biology and stuff. And they have a lot of resources in there, like between course handouts, lecture slides and stuff. That should be some direction over there. Also, there are other open source communities. I'm part of a couple of them. I'm happy to connect you all with, I'm happy to connect whoever comes into those communities. I'll send you some of the links, like Discord channels and everything for those things.
Perfect. That's amazing. So that was a very nice thing, and happy that you are able to connect with so many people and grow. You've grown to such a great levels. That's nice. You happen to do electronics as your BS major, and then you electrical and MS, and then you happen to do a PhD in computer science now. So how was the transformation, and why did you shift to computer science?
I mean, it's actually very weird, because I thought I'd just do like another PhD in electrical engineering. At least in my lab, it didn't matter what the course was, right? Like what branch I was in. It probably would have changed like what courses I need to do for like my qualifying exam, but that's about it. But when I had to make the trade-off, right, like there were a couple of things that went into it. Like towards the tail end of my master's, I actually understood, like how funding for grad student works, because I was working in a lasers lab at that point, and I understood like how funding works for grad students, how professors get grants, how they're dispersed, and how they decide, how they make these decisions. And at that point, I realized that everything is a tool, right? Like for somebody like me, everything is a tool. You decide how to use it, you learn how to use a tool, and then you apply it however you want. And then the second thing was, and the second most important thing was, who's your advisor? That's the most important thing when you're deciding on a PhD. Like, it doesn't matter what you're doing at some level. Like, you could be like designing, I think there's a famous example another grad student gave, that, you can be designing chairs for all you know. It doesn't matter as long as your advisor is good. So it can be the most stupid thing, but if your advisor is bad, it might be the coolest thing. But if your advisors are not a good person, they're a bad manager, they don't know how to handle grad students or how to delegate tasks and everything, or how to help their careers, you'll basically shoot yourself in the foot. So which is why when I met my current advisor, I was like, I saw how he was with his postdocs, how he was helpful for building out their future careers and stuff. And that was something that made me decide that, yeah, this is a place I want to do. Now I don't care what degree I do. And of the projects in the lab, I picked something which was for the design automation part of it. And so that meant a computer engineering PhD. So I just went with that. As somebody who used a lot of design tools as an electrical engineer, I thought I had a lot of opinions I could put into my own design tools. So it was kind of like a very, there's no grand explanation for it. It's very simple.
That's nice. That's nice. That's amazing. So I think it has driven you towards your destination. Something has driven you.
Yeah, I mean, you got to work with what you have, right? Like, you can always say, oh, I want to do something like that. The most important thing is figuring out where you are and figuring out what impact you can have. And if I didn't go down this path, I wouldn't have figured out, like, I have a certain impact path in my mind right now, and I wouldn't have figured that to be the way if I didn't end up taking up a computer engineering degree over here. So
true. That's nice. So that brings us to a grand completion of the whole interview, and thank you for your time. And what is the message you would like to convey to the current audience listening to you?
I mean, I think the most important thing is do what you think is good for, everybody has their own motivations. Be true to yourselves. If making money is what's important to you, go do that. If helping others is what's important to you, then go do that, right? I think science and engineering has a way to like help all of that, but it doesn't only need to be the case. What I've realized is that, over time that, social systems are harder to engineer. They're probably the most complex problems to solve. So, if you decide to go down social sciences or something, that's not a bad idea, because we need people to figure out like societal problems and figure out solutions for that. But yeah, just be true to yourself, do what makes you happy, and, just be a little pragmatic about things, and don't work in toxic environments. You basically you don't want to like absorb that toxicity in your life. It's not worth anything. So go out, do something else, like figure out what it is, like, but don't help sustain toxic environments. I think that's the most important thing I'd like to put forward.
Amazing. That's so great, and amazing message and amazing way you conveyed it. So thank you so much, Radhakrishna Sanka, or Krishna, for being a part of TWF Talks and sharing your knowledge and your ideas of how an engineer can grow over the years. So thank you so much for your time. Wishing you great successes further.
Yeah, thank you.
Thank you so much.
Have a nice day, Amrita. Bye.
You too.